Claude Opus charges $25 per million output tokens. DeepSeek V4 Flash charges 28 cents. Same unit, about 89 times cheaper. And on DeepSeek's published terminal bench result, only 2.3 points separate them. That sounds impossible. So I checked the benchmark conditions, then gave the cheaper model 3 ordinary repository jobs, a backend bug, a failing test, and an authorization hole. It passed every hidden check for roughly 1/10 of a cent. Then the experiment broke anyway. The price gap is real. The coding result is real. The failure was real too, but it was not the code. So the useful question is not whether a 28-cent model is Claude. It is how much verified work it can remove from Claude's queue. On July 31st, DeepSeek published the official V4 Flash 0731 checkpoint, replacing its preview. The weights are open under the MIT license. The context window is 1 million tokens, and the release is explicitly trained for coding agents and tool use. DeepSeek's table reports 82.7 on terminal bench against 85 for Claude Opus. On DeepSWE, 54.4 against 58. On ToolAthlon verified, 70.3 against 76.2. Close, then less close as the work spreads across more tools. But those rows are screening evidence, not an independent head-to-head. DeepSeek used its own minimal agent harness, maximum effort, and specific sampling settings. Terminal bench itself says the thing being tested is the model and agent together. Change the harness, and you can change the score. My test was deliberately smaller and stricter. 1 fixed Python repository, 3 tasks, a confined file tool, public tests the model could run, and 14 hidden checks it could never see. This was not a comparison against Claude. There was no second attempt and no editing the tests. First, an inventory function rejected a reservation equal to all remaining stock. The model read the task, found the greater than or equal boundary, changed one operator, and preserved the check against overdraw. 4 hidden inventory cases passed. Second, page 0 was leaking through a 1-base pagination function. DeepSeek widened the existing guard to catch 0 and negative values. The public failure disappeared. 4 more hidden cases passed. The tests were untouched. Third was the dangerous one. The invoice check allowed any signed-in user to view any owner's invoice. The model separated anonymous, admin, owner, and stranger, fixed the condition, then wrote a security finding that described the bypass. 6 hidden checks passed. 3 jobs passed. 14 of 14 hidden checks. 4 of 4 public tests. 4 intended files changed. 0 test edits. 0 human corrections. For bounded work with a grader, this was not almost usable. It was clean. But benchmark bars hide something important. The model finished the repository work in about 2 minutes and 10 seconds. The harness did not exit until 5 minutes and 10 seconds because the final confirmation request stalled. Same run. 2 very different clocks. OmniRoot had sent the model through NVIDIA's endpoint. Before the work completed, that route logged 16 temporary overload responses. Retries recovered, the code survived, but predictable latency did not. Cheap tokens do not automatically buy a dependable agent service. This is why the harness matters as much as the model. It checkpointed the transcript, preserved the edited repository, and ran the grader without waiting for the model's final sentence. In production, retries, timeouts, and verification are not plumbing around the product. They are the product. The 4 successful model responses used 4,997 input tokens and 1,255 output tokens. At DeepSeek's published list price, that is $0.00105, about 1/10 of 1 cent. That is not a receipt from DeepSeek. This run used a third-party route, so it is a price equivalent calculated from return usage. And it is not total agent cost. The real equation adds retries, review, corrections, and the blast radius when a wrong change escapes. Still, the token gap is too large to ignore. Claude Opus output is $25 per million. DeepSeek is 28 cents. Even if the cheap route needs supervision, routine verified work has enormous room before its operating cost approaches the premium model's token bill. For bounded reversible work with strong tests, use DeepSeek first. Routine bug repair, test maintenance, migrations with deterministic checks, and repetitive repository maintenance. Keep the task small, checkpoint every turn, and let verification decide whether the model is done. For ambiguous debugging or longer changes, start cheap and escalate when the evidence turns bad. A failed grader, repeated wandering, unnecessary file churn, or a correction that costs more than the token saved. Escalation should be a rule, not a mood. For architecture, security boundaries, destructive migrations, and systems with poor test coverage, keep the stronger model and human review in front. My tiny authorization task passed. That does not prove this model can reason safely across a real company's permission graph. So no, 28 cents does not buy Claude, but this run says it may buy enough verified work that Claude no longer needs to be your default. Use DeepSeek first, escalate difficult work, and never confuse a cheap model with a cheap system.